Hey folks, Father Sampati from CGVirus here. Today we're going to see the fundamental key concepts of blended geometry node. So basically these concepts has helped me to understand geometry nodes better. So I hope it will help our community as well. So basically we are not going to do any kind of complex node setup here. We will see the bare bone basics so that we can clearly explain everything here. And these tutorial will be a bit lengthy, so I will mark the chapters so you can repeat it if you are not if you get confused. All right, so let's get started and let's see. Okay, first thing first is basically what is geometry nodes. So we're going to give a high level understanding here. All right, so geometry nodes is a flow-based programming interface. So flow-based programming is basically a programming paradigm. So for this paradigm, geometry nodes gives us an interface to work with, and with this interface we can manipulate the geometry data graphically through math and algorithms, and this math and algorithms are represented by nodes. All right, so let's have a high level of understanding here first. Suppose this is a box, and we have added a geometry modifier here, geometric modifier. So currently this geometry node modifier is inputting this box as a geometry, and it is outputting this box itself as a geometry. So if we cut it, it will be gone. Why? Because it has no input, no output right now. So let's connect it here. So geometry in, geometry out. Okay, so now let's create an algorithm first. So suppose this is the edit mode, and this box has if we go here, this box has a bunch of points, right? And these points are situated in our Blender world, XYZ world, three-dimensional world. So these points have a position value in this XYZ world. So if I go to our 2D Cartesian graph, you can see that here is a point, and it is situated in y-axis 3 and x-axis 5. So it is situated at 5 and 3 position, right? So similarly in 3D we have z-axis, and all of these vertices is positioning somewhere. You can see this is the position value. You can see it is changing, right? So what we want to do is basically we want to create an algorithm, an instruction, and this instruction, with this instruction, what we want to do is basically we want to know the position value of all of these vertices, that is these guys. Okay, all of these vertices, we want to know these vertex positions, and what we want to do is basically we want to add one somewhere here. Okay, so we want to add one to all of these vertex positions. So you can see it has become 2, 2 and 2, something like that. Okay, so we want to do this algorithm. How can we do it? Algorithm, what does it mean? Algorithm is basically instructions. Okay, nothing else but instructions. So we want to do it like that. So to know all of these vertex positions, we need to have some nodes. Okay, so let's say Shift A, geometry, read. Okay, so read what I want to read. I want to read all the position of this geometry. I mean vertex positions of this geometry. Okay, see these vertex positions. I want to know all of these vertex positions of this geometry. That's why we are using this read node. Shift A, geometry, read position. Okay, read the position, that is get position. Okay, let's say it is not position, it's a let's say get position. Okay, Now what I want to do, I want to just add 1 to each axis. Okay, I want to add 1 here. So what we can do, okay, to add 1 we can create a vector math. There we go. It's already in add, so let's connect it, and let's add 1 to each axis. Okay, axis to each axis. But you can see nothing is happening here. We have already created the algorithm, we have already created the instruction, but it is not doing anything. Why? Because it is not connected yet, it is not applied. Okay, we need to apply it somehow, right? So how can we apply it? Well, we have we can go to Shift A, geometry, right, set position. Okay, let's connect it here. So these are get position, this is get position, we are getting the position, something like this. Okay, selecting it and get the position, we are getting all the positions of these vertices. Then we are adding 1 to everything. Now we need to set it, right? We need to set it. So let's set it. Here we go. Same thing is happening here, right? So these two, these are called fields. Okay, and this is a control flow node. These are field nodes, these are called control flow nodes. Okay, we will talk about it later, but I just want to give you a high level of understanding how geometry node works. Okay, so this is the inner workings. So we are inputting something, okay, something. We are creating some algorithms, we are creating some instructions, and we are applying it to our geometry. This is the basics. Okay, so all right, so now next we are going to talk about what? Yeah, data structure. So let's get started and let's see. All right, so data structure of geometry nodes, actually data structure of Blender itself. Okay, so data structure means, you know, how Blender pack its data, how Blender pack geometry data. Okay, so we need to understand it. So if we go to the lowest level possible, I mean the atomic level, if we go to the atomic level, then we will understand a very weird thing. Let me show you. Computer, what is actually data? Let's understand this first. Data is nothing but bunch of numbers in a computer world, in a digital world. Data is nothing but numbers. Okay, it has no meaning by itself. That means, let me show you very interesting thing, color. So we are calling it color, but beneath it you will see there are actually bunch of numbers. Okay, so it's a 4-channel number with alpha and RGB. So if we want to create a red, perfect red, what we can do is basically we can go red 1, green 0, blue 0, so it becomes a perfect red, right? So what we are actually doing, we are actually saying our program, our computer, that give this 4-channel value a 1 0 0 1, then it becomes red. So basically these numbers doesn't mean anything. What we do is basically we create these numbers and we interpret it. Okay, then it becomes information. So data itself has nothing. So data has nothing. What we need to do is basically we need to give it a meaning. We need to give it a meaning. Okay, suppose number 6. So computer has a number that is called number 6. Okay, let's go here. let's go to our sheet. Yeah. Okay. Number 6. So number 6, does it has any meaning? No. We can say number as age. We can say it's a size. We can say it's a season. So whatever it is, all right. So 6 itself is meaningless. We give it a meaning. Okay. 6 can become an age. 6 can become a size. 6 can become a season. 6 can become a list. Whatever. Okay. So when we give it a meaning, it becomes an information. Okay. So data with a meaning, with an interpretation, becomes a meaning. So that is the data. Okay. Now there is a very wonderful thing. Suppose what you are listening right now, it will have some kind of something like this of waveform. Okay. So what do we have here? Well, guess it or not, these are also numbers. It is from 0 to 1 and in between. So 0.2, 0.5, 0.6, whatever. And it is creating a voltage drop. And then we're interpreting this number as sound. Okay. We're interpreting it as sound. It will become a vibration, and then you will interpret that sound. This is fascinating, right? This is fascinating itself. So with these numbers, we can actually drive. We can interpret this number as color as well, right? Because color is also numbers. So we can directly convert it into colors. Okay, that's how histograms and the audio visualization, these things works. So we can interpret it as colors. We can also interpret color as sound. This is crazy. So number, that's why number is one of the crazy invention for digital world, and it is working pretty nicely as well. So these are called data. How can I erase it? Yeah, let's go. There we go. Okay, so these are data. So similarly, our box, actually, let's cut them right now. Yeah, our box also has these thing, data, simple data. Okay, so it is situated in a 3D space. These vertex, these are situated in a space, in a position, in a vertex, in a position in this 3D world. Why it is saying 1? Let me show you. Okay, let's go this one. Let's grab this one, this vertex. Okay, here we go. So you can see, if I go to the wireframe mode, you can see. Okay, so this vertex has a name, and the name of this vertex is number 6. Okay, you can see an ID 6. So it has a name as well. So we are naming it 6, number 6 vertex, and this number 6 vertex is situated in let me see, -1 meter, -1 meter, because x is here. Okay, you can see it here, x is here. So if I go here, it will become plus. Okay, it has become plus. If I go here, so it has become minus. So it is in -1 meter or -1 unit, x, plus 1 meter or plus 1 unit, z. So this is the 0. Okay, if we draw it here, so 0, it is 0. This is x1, sorry, this is x minus, this is x plus, this is z plus, this is z minus. And if we go to 3, that means top level, let's go 7. Yeah, this will become y plus, this is y minus. Okay, so where we were, so yeah, z, so this is z1 meter, it is in z1 meter, and if we go to the top 7, it is in y1 meter minus 1 meter as well. Okay, so it is situated in this position. Okay, you can see. So what is it? It is nothing but a data, right? So it's a data, it's just a data, it has a position value, nothing else. So number 6. Okay, so these are called data. Alright, so we have talked about data. So now let's talk about other stuffs, attributes. So what you can see is basically we have all the vertices data here, and you can see there are a lot, right? So what we need to do is basically we need to pack it, and with packing it we can actually organize it a little better, right? So these data which we have here are basically what? These are basically vertex position, right? That is point position. So let's name it, let's collect all the point position we have and let's pack it in a name. So this packet is called attribute, and the name of this attribute is position. All right, so basically attributes are packages that contains the data. Like, if I go to the vertex group, I'm creating 3 vertex group here. So this is group 01, group 02, and everything. And let's just select this and assign something. So this is the number 6 vertex, and we have assigned 0.588 to this group. So these are all these are weight. Okay, 0.588 weight to this vertex, singular vertex. So let's pack it, and let's name it group attribute. So that means we are packing this data into a package, and we are calling it attribute. So data packaged to attribute. Later you will see that we have lots of attributes as well. Okay, so we need to further package it into domains. So what is domain? Well, for now on, so far we have actually only talked about vertex, but Blender has other domains as well, something like edge. Okay, if we go to the edge, we will see these are the vertex, these are vertex domain. Okay, these are edge domain, face corners. Okay, so that is UV map. So domains contains the appropriate attributes. That means the vertex domain will contain the vertex attributes only. It will not contain the edge attributes. Edge has their different attributes, face has their different attributes. Like, if I go to the face, press 3, let's select these, you will see there is a shade smooth and shade flat something. So we can create, we can do it like this: shade smooth, and this is the face number 1. It has a boolean of shade, sharp face, right? So 1, so it has become shade smooth. So let's create shade flat, so it becomes true. Okay, true and false boolean. So if we go to shade smooth, this domain doesn't understand this domain. That means this face domain, it doesn't have any meaning, right? So face has a sharpness, face has the normal sharp, right? But vertex doesn't contain this kind of information, right? So doesn't mean it doesn't mean anything. That's why we have the attributes in domains, okay, in their own domains. So vertex should have vertex attributes, face should have face attributes, edge should have edge, face corner should have UV, so something like that. So these are called domains. Now another fun part is basically we have various kind of object type in Blender, okay. So these are called components. These are object types. Suppose this curve, okay, this curve is a curve component and it has curve specific domains and it has curve specific attributes, curve specific data, right? So it doesn't make any sense to have some data in mesh because it's not a mesh. It's not a mesh component, it's a curve component. Just like that, it has this is a volume, so it should be in volume grids, right? So it has volume grid data. So the volume, it doesn't make any sense to have data in mesh component here, okay. So it doesn't need mesh component data, so it is 0 0 0 0, everything is 0. So it's all about classifying it, packaging it, nothing else, okay. So and these components are creating the final geometry, okay. So if I go simply, then first there is a geometry, and geometry has some kind of mesh component, not mesh component, some kind of geometry component, object component, and this object component will have some kind of domains. These are the domains, okay. Then these domains will have some attributes, and these attributes will have some data. So data to attributes to domains, domains to components to geometry. So this is the data structure: data, attributes, domain, components, geometry. So you need to understand these data structure very well because you are going to manipulate this geometry according to domains and components. So very important. All right. So if you're confused, go to the spreadsheet and you will understand it very clearly because the spreadsheet has very clearly grouped them very efficiently as well. So these are the datas, attributes, components, domains, then components, okay. And finally the question is, so what is geometry? Well, geometry is something that falls into a component category. So if you just want to define it, but geometry itself has a very scientific formula. If you go to the Cartesian graph and everything, it's another topic, but we're not going to do that. So yeah, that's it. So there are also another kind of components like armature. Armature is armature component, okay. We have also light type of component, but we cannot access them. Like we cannot access them with geometry right now, but I guess very near future we will. But right now we can't access them. We can only access mesh components, curve components, point cloud components, volume grids, and instance. Okay, there we go. So that's it. This is the data structure of geometry nodes. So if you are confused, then recap it. Okay, recap the chapter, and I hope you will understand it pretty well. And take breaks. Okay, lots of information. Take some break, then come for the next topic. We will talk about node types. So let's see. Okay, so node types. Blender geometry node has two types of node mainly. Number one is field nodes, and second one is data flow nodes. Okay, so what are data flow nodes? If you have come from object-oriented programming paradigm, then you will understand it very clearly with the word setter. Okay, so these are basically setter functions. So what it does is basically it will grab the instruction we are giving to a geometry, and it will set the resulted data into the geometry. Okay, so what do you mean by that? For to understand that, we need to go back to our basic algorithm we had. So what is algorithm? Algorithm is nothing but a set of instruction. These things, okay, after start, before end, these things are called algorithm. We are creating a step by step algorithm. We are creating a step by step instruction, so that is called algorithm. So let's see what it says. Start. Create a function to do these steps. Step 1, let's know all the vertex position of the geometry. Step 2, add 1 unit to every vertex position. So we need to create these two functions first, then apply these above function to our geometry. Very simple. So let's go here. Yeah, so what is saying, create a function to know all the vertex position of the geometry. Okay, so that means we want to know all the vertex positions of this geometry. So what we did here, basically we need to read our position values. So it will read all of our vertex position, then add 1 unit to every vertex position. That means it needs to be 1 plus 1 equal to 2, minus 1 plus 1 equal to 0, something like that. Okay, 2, 0, 2, 1. So let's add it. How can we add it? As it's a vector, we're going to create a vector math position, add 1. Okay, now these two are functions. Okay, this function, what this function is doing, this function is grabbing all the position value, vertex position value we have in this particular box, and this particular function, what it is doing, it is adding 1 to these vertex positions. Okay, so now we need to apply this above function, right? Apply this function. So how can we apply it? Well, it's if you apply a common sense, it's a position, right? So we need to set this position, right? So we have geometry, right, set position. Okay, fantastic. So grab it here and apply this position here. Here we go. Now it has become 2, 2 and 0, 0. So these are fields. We will talk about it later. Let's talk about this set position first. So if we go to our presentation here, so data flow nodes have a geometry socket. You can see this is the geometry input, this is the geometry output. So that's why it's called data flow nodes. It flows around the geometries, and what it does nothing but apply whatever the function we have here. Okay, so it's applying it. If we disable it, it will do nothing. It needs to be applied here. Then it will apply our functions. Okay, what is function? Function is basically a set of instructions. So these are instructions, right? Grab the positions, add 1. So these are all individual instructions. So these instructions are going here to the flow node and applying it to a particular geometry. That's all. So data flow nodes has some examples. The writes nodes, set position, set ID, store name attribute. Okay, no problem. So the write nodes, basically the write nodes. So geometry has a write node, set ID, set position. You can see the set ID also has a geometry input, geometry output. So if we go to the curve node, we have some write nodes, set curve normal, set curve radius. You can see this has a geometry, but it needs a domain. I mean the component should be curve anyway. So these are all geometry nodes. So something like mesh has a write node, set shape smooth. Okay, geometry. So we can execute it here. By default, we have a implicit property here, but we can actually create a boolean, suppose boolean, yeah, we can connect it here. It will become also, yeah, it's doing the same thing. So anyway, so these are called control flow nodes. So this control flow nodes applies our particular instructions. Okay, so these are control flow nodes. Simple. Now we are going to talk about these field nodes. These are the bigger one. So let's see. Okay, field nodes. So what is a field node? If you have come from programming paradigm, programming fields, then you already know what is field. Field is basically a function. Okay, so if you have not come from a programming world, then we need to explain function a little bit. Okay, let's see these calculator. Okay, and there we go. So this calculator has this add button, right? So what does this add button do basically? Well, this add button doesn't do anything itself, right? So what we do here is basically we give it something like a function, func, and add. Okay, func add. So what it will do, it will basically use two variables. Suppose one is x equal to suppose 1, and y is equal to suppose 2. So does this add function has any idea about any kind of number? Suppose if it doesn't have an x or if it doesn't have a y value, then what this add will do? It will do nothing. It will output 0 always, right? Because it doesn't know the x value and the y value. Basic algebra. So this is actually function. So we need to put some value here. Suppose x is equal to 3, y is equal to 2, then this add function can work, and this add function will give us 3 plus 2 equals 5, right? So that's what the calculator does. Okay, simple. So function itself cannot do anything. It needs to have some kind of information data, right? So if we can give it a data, it will calculate these particular thing, right? So in this sense, this is basically this s plus y is basically an algorithm. Okay, it's saying that take the x value here, take the y value here, add it, and give us the result. So this is the function. Simple. So a very interesting part is if we change the y value, suppose to 5, will it give us 5? Absolutely not. It will give us 8. 3 plus 5 is equal to 8. So you can see two features of function. Number one is it has no value itself. No value. Okay, itself it has no value. Number two is it needs some predetermined value, that means variables. Okay, these are called variables. So it needs predetermined data or variables to function, to do its calculation, right? So it needs data. I need data, otherwise I can't work, right? And number 3 is as it has no value and it depends on data, the result will vary, right? You can see that we have 3 plus 5 now, so it has become 8. If I go for 5 here, okay, it will become 10. So it varies, okay, according to the value. So these are the these are some features of function. So why do we use function in programming? We use function. It's very simple, you know. Always these variables will change, right, at some point. So we need to pack our algorithm efficiently to use it repeatedly. All right. So we can use this add function again and again, right? So if it's 5 plus 5, then we can use 10. If it's 3 plus 4, it will become what, 7, something like that. But if we just do x plus y, something like 5 plus 5 equal to 10, it can't change it, okay? It can't change. It is 5 and 5, it will always be 10. But if we create a function, then we can change it, right? We can change the variable value and we can change it. So now it has become 11. Magical, right? So that is what function is actually in a nutshell. So so now we have understood function a little bit. So now we can work with our fields. So here, so let's see. Okay, so field nodes has 2 types of nodes. All right. So number 1 is a field input node. So if you have come from object-oriented programming paradigm, then you will understand it with getter. Okay, these are actually getters. So if you have not, then let's explain it. It is an input node, captures the data of an attribute of a context geometry. Okay, so what does it mean? Suppose these particular example, in this particular example, suppose we have a grid, okay, and it has a box. So suppose this box is situated at x equals 5 and y equals suppose 5. Okay, another one, if we go here, another one is situated slightly higher, somewhere here. So suppose this box is situated at x plus x equal to 7 and maybe y equal to 9. Yeah, y equal to 9. So this particular function we had, function add. Okay, so this function add, what will happen to this particular function? What will happen is basically this add will result 5 plus 5 equals 10, right? But this particular geometry, this particular box will have a result of 7 plus 9. That means 9, 10, 16. Okay, so this is the context geometry. A function requires geometry, we told about earlier, no value and everything. So it's a context geometry. So if this geometry is giving us 10, this geometry will not give us 10, this geometry will give us 16. Different, right? So it needs a context, it needs a reference. So that means it will be different, right? For this geometry it's a different, for this geometry the result will be different. Different results, but same function. The function is same, but the result is different. Very important part. So we're going to recreate these particular function now to see some interesting things. So we have this green box and we have this red box. What I want to do to give you those understanding, I'm going to top it 2 unit up to z-axis. Okay, so now you can see it has three values. Okay, where this one has all 1 and -1 everything. So can we demonstrate it here? So let's cut this geometry, we don't need it. We're going to import this green and we're going to import this red. There we go. So now we're going to join it as well. So let's join this geometry. Join geometry. Let's join them together, right? And let's output it here. I think we can hide it. Okay, so this is green, this is red. Yeah, so I was hiding this cube, so that's why. Yeah, and let's give it relative. Okay. So relative means the object relative transformation. Okay, so now if we simply put our input field. Okay, let's talk about the input field, these things first. The input field will have a diamond socket as output. These are field node as well. So example, the reads, position ID, etc. So yeah, so you can identify these field nodes, input field nodes with a diamond socket, and these are basically read nodes like geometry read ID. You will see there is a diamond socket at the end output. Similarly, read node position, it also has a diamond socket. So these are read nodes. Let's go to curve read here. Suppose this one, it has a diamond socket. Actually, no, not this one. Curve read, curve tilt, yeah, it has a diamond socket. So these are input field nodes. Okay, similarly we have mesh read. Okay, it has a diamond socket. So these are input read nodes. What it does, very simple. What it does is basically suppose this position node, it by itself it doesn't do anything. Okay, it needs a context geometry. How can we understand the context geometry? Well, let's go to the viewer, Control Shift. Here we go, the geometry. This is the green one, and let's select this position here. Okay, so you will see it is outputting some results, -1, 1.013, and something, right? 3. So this is the green one. Okay, now if we change only the geometry to red one, what it will do? It will give us something else, right? The position has been changed. Why? Because as we have told earlier, simply it's a geometry context. Okay, it needs a geometry. By default it will give us nothing. This position has nothing in it, right? So what it is doing, if we connect it to geometry, then it will give us the position. So position means get position. Okay, Shift A, geometry, read position, get position. So get position is a function. This function, what this function is saying, give me the position give me the position attributes. That means give me the vertex positions this particular geometry has. And for this particular geometry is green box. Okay, this green box. This green box has these positions. So you can clearly see the flow of this node is something like this. It's getting back. Okay, it's getting back first. Then it will give you the result. So field nodes are basically works in back movement. In general, the nodes are left to right, but field nodes will go something like here. Here we go. So it will go here, geometry, then go to the position. Then it will retrieve the position and it will send out the position. That's why it has a dot noodle. Dot noodles mean it can go left and right. Okay, so it is going back and then front. So that is the important part for field nodes. Okay, so these are input field nodes. This is a function. This is saying give me the positions, give me the position values, vertex position values of this particular geometry, not not the green one, not the red one, but whatever it is connected with. So if it is connected with green, it will give you the green box position values. If it is connected with this red one, okay, it will give you the red position values. That means the red box position values. So it is a context sensitive thing. Okay, so it requires a context. Otherwise it will do nothing because it has no value, right? The thing we did earlier, it has no value by itself. It needs a context. I think it is now clear. All right, so let's do some magical parts here. So let's create a flow node here. Let's give it geometry, right, set position. Let's give it both the set position here. The problem with geometry node is basically it becomes very cluttered. That's the one problem. Anyway, so set position. There you go. So I'm just going to hide it. Control H, Control H. Okay. So we're talking about position here. Let's go. So now what we can do is basically we can connect it the positions. Okay. By default it is not doing anything because it is just reading our stuff. So what it is doing is basically is going to this green one, this green box. It is going through this green box, set position, ting. Okay, what do we have? Okay, I am connected with green box. Okay, do we have any selection? No. Do we have any position? Yes. Okay, let's go here. It is going backward, and this is asking for, hey, get position. Give me the position of this green box. Give me the vertex position of this green box. This function will say, okay, yes, I have the position. I'm sending you back. So it will become position. The sound effects. Okay, so it will go back to the position value, and then it is setting the position. Right now it is not doing anything because we have not given it any kind of instruction. Okay, so this is how these get input fields works actually, the read nodes. All right, here we go. Number one done. So number two is actually very basic. So these are called instructions. Okay, function nodes. The second part of field node is function node. So function nodes, these field nodes take the field input, process them as par instructions and output the result. They have diamond sockets as input and output. These are field nodes as well. Of course, it's a field node. So examples are the samples, the utilities. Let's see. So if we go to the shift A, suppose sample, geometry, sample, you will see that there are some nodes. So suppose geometry proximity. So what it was saying, they have diamond sockets as input and output. Diamond sockets as input and output. Here is the source position. Okay, diamond socket. Here is the position. It will output a position. It will also output a distance. Geometry proximity is a domain specific, so that's why it has these things. Okay, let's go to another thing like mesh. Mesh also has sample near a surface, diamond socket. Okay. Also we have utilities, so let's go to utilities. Okay, actually we were working with vector math here. It also has diamond socket. So let's add them. 2. So it get the inputs. Now you will see a very funny thing. Let's increase the z value a little bit. You can see what it is doing. It looks obvious, but it is doing a very complex thing. So let's give it 2. What it is doing is basically the same thing. Remember, the field nodes itself cannot do anything. It needs a context, right? So it is going to the green box and it is going here, something like that. Hey, the position. Okay, hey, add. Here we go. So something like that is happening. So it is going to the add node and it is saying, hey, give me the position. The add node is saying, hey, give me the position. Okay, here is your position. All right, ping it back. It is ping it back. Then it is adding the functions. Then it is resulting in giving the output to the set position. The set position, the control flow node is setting it up. Okay, so the question is, why this green is higher than the red? So if the field would have some kind of default result, default number or default values, then the red and the green should be in the same position, right? In the same, something like this. It should be somewhere here, right? But it is not. Why? Because it's contextual. Here, the red one is saying the same thing. It's saying, hey, geometry, give me the position. Back. Now it is saying, hey, vector, go to the position value first. And then it is giving the position. So now this position is giving the red position in this socket. Okay, this one is giving green, this one is giving red, but the function is same. You understood? That means it's all about context. So one single function giving two different output. Okay, so that's it. So if I go to the viewer node now and show you the factors there, you will understand it much more better. So let's go to the viewer node. So it is in geometry. I'm going for this add. Now you can see it is giving us something like -1, -3, but I just want to change this geometry here. Boom. It will giving us something very different, but the function is same. The function is same. You can see the function we have is same, add, but it is giving us different result. Why it is giving us different result? Because it is a geometric context. It is going backward. It is asking for the particular geometry information. Okay, Here we go. So hopefully it has cleared some of the confusion. I know the field is something non-programmers will have some struggle with, but I hope this particular example has cleared it out a little bit. Hope so. Anyway, so this is field. Okay, so another feature of Blender Geometry Node is attribute propagation. That means holding attribute for future use. So we're going to see it in a very basic way. So let's get it started. So we have a cube, basic cube. What I want to do here is basically I want to create an icosphere first, and I want to point instance. Okay, I want to create some instance here. Instance to point, not this one. Instance on points. Yeah, this one. And what I want to do here is basically I want to instance some icosphere on the points we have in our box. Okay, so yeah, now what I want to do is basically I want to create a set position node before this geometry, and I will also want to join this geometry here. So join the geometry. Yes, there are other routes we could use, but I'm doing it to show you the attribute propagation system here. All right, so here we can see pretty easily what is happening. The thing is happening here is basically we are having a box. It has a bunch of points. We are just instancing some icosphere into that point. Simple. So now you can see here there are the positions. I can offset it. I can change its position, and it will follow the points. So that's why the icosphere is also following the box. Simple. Now what I want to do, suppose that I want to change this position of this box, but I don't want to change the position of these icospheres. That means I want to store the previous position. I mean previous positions like 0, 0, 0. I want to store this position first. So what can we do? Well, for these we have geometry attribute store named attributes. So what does it do? Let's see. So store named attributes, we can insert it where we want to store attribute in our flow. So I want to store a vector of point, right? I want to store the position. So let's give it position. There we go. And let's name it. Let's name it like current position, something like that. So it will become a position attribute, right? So it is currently storing the current position of our attribute. Now if I change this, you can see that the current position is the box position is changing, right? It's changing, but the current position is storing the previous value, right? So it's all about flow. So I'm setting the position here. It is working, but before setting the position, I used a store named attribute to store the previous position. Okay, so yeah, See, the current position is not changing, but the position is changing, right? That's it. So now what we can do is basically we can use these created attribute. We have created this attribute. Okay, this is the custom attribute. We have created it, and we can use this attribute as well. So how can we use it is basically let's use attribute. Should be in read geometry read named attribute. Okay, so this is store named attribute, which is basically a set attribute. Okay, and named attribute is basically a get attribute. Okay, so now we can use it like vector, and we can go to the current position. So this contains our current position, these guys, current position attributes. Okay, so what we can do now is basically we are instancing these points, right? So we can actually manipulate these points position value as well. So let's create a set position. Yeah, and now we can actually change our instance position, right? So now we can use our custom current position we have here. So let's clear it up a little bit. There we go. And this is the named attribute. So let's just connect it here. There we go. So now if I offset my box, you can see that it is using the named attribute position instead of the box attribute position. So what it is doing is basically very simple. Okay, let me mute it. There we go. Okay, so I'm just setting a position and giving my previous position values here. Simple. Okay, we can offset it as well. So I'm just giving it my previous position. So let's make it 0. Here we go. So this is how we can store an attribute, and we can use it later in the flow. Okay, in future flow. So that is called attribute propagation, holding attribute for future use. You will need it. Okay, sometimes you will need these kind of attributes. So holding your attribute for future use. Here we are using the attribute here. So there is another concept that is called anonymous attribute. Sounds cool, but it is doing the same thing we have done here. What it does is basically capture node, capture attribute. Okay, so let's delete. You can see that we have created an attribute and storing it to use it in future. The same thing we can do with capture attribute as well. So let's connect it here. Let's mute this guy because we don't need it. So there is no current position now. So everything has lost. So let's actually delete this named attribute. We don't need it anymore. Actually, let's disconnect it here. Okay. So what we can do here is basically in capture attribute we can create the same thing, vector, and and let's just connect it to the position. So now you can see that there is no attribute is showing. There is no attribute. Actually, what it is doing, the capture attribute, what it does is basically it creates a nameless attributes. Okay, nameless attribute. It will create a nameless attribute. That is why it is called anonymous attribute. Anonymous meaning nameless. Okay, nameless. So what we can do now is basically we can connect this attribute to the position, and it will do exactly what we did with named attribute. So this is the thing. This is called anonymous attribute. So we were creating before we were creating an attribute and we were assigning it to the position. Right now we are not creating the attribute, rather we are capturing this attribute, and these attribute will be stored somewhere in Blender in memory, and it can be used later in future in our flow. Okay, so this is how the anonymous attribute works. Anonymous means it is nameless because you can see any attribute here, right? So that's why it is anonymous attribute, and we are using it for future, in future. Okay, so if we disable these and enable these instead, same thing is happening here. Okay, same thing is happening. So let's just connect it here. See, same thing is happening, no changes, right? Yeah, simple. So that's it. So attribute propagation, this is the attribute propagation. So we are storing some position and using it in future, or we can actually disable all of this. We don't need to store it, we can store it virtually and we can use it later. That's all. So this comes to the end part of attribute propagation. So yeah, store named attributes, set attributes, and named attributes are get attributes. If you are from programming paradigm, then you can call it set attributes and get attributes, and these are anonymous attributes is actually capture attribute. Capture attribute creates an anonymous attribute. That means capture attributes are nameless, stores a nameless attribute. That's all. Capture attribute creates an attribute and it is nameless. That's why we can't see it in our spreadsheet. But both are actually same. Okay. So that's it actually. So we have learned what is actually the geometry node is. Then we learned the data structure of geometry nodes. We learned about the node types. There are two types of nodes. One is field nodes, one is data flow nodes. Field nodes has two types of node, field input nodes and function nodes. And field nodes has diamond socket as output. Function node has diamond socket as input and output. Data flow nodes will have a geometry socket as input and output. We talked about field, what is actually function. Fields are actually simply functions that can be passed by reference. We talked about what is function and what is reference. Reference means the geometry itself. And the data flow of field. Data flow of field is backward. It needs a context geometry, the reference first to grab the data from. And we understood that attribute propagation, holding attribute for future use. That's all. So that's it. I'm Father Sampathik from Cityvirus, and we're going to see you next time. Bye bye.